Alright, section 9.3 is an excellent review of matrices and vectors. We're just interested in derivatives of matrices and integrals of matrices. To make a long story short, if you have each entry in a matrix dependent on t, then the matrix becomes dependent on t. We call it that's a function of t, or a matrix function of t. Same thing with a vector. And if I want to take a derivative, assuming that t is continuous and differentiable, you simply take the derivative of the entries, and if you integrate, you would integrate the entries as well. It's really straightforward, not much to talk about. 3 rules. The third rule we're not gonna use. We're gonna do an example on it, but this is not something that you have to remember. But you should remember those two for what's to come. If I take a derivative of 2 matrices, one of them is a constant. Just like calculus, you ignore the constant vector. You take a derivative of a, the varying function, and you multiply the results. If you take a derivative of 2 vectors added, you take the derivative of the first, derivative of the second, and add the result. And if you take the derivative of 2 vectors multiplied, now the ordering here is a bit annoying. A times the derivative of the first plus b times derivative, or derivative of the first times b. It turns out in this case you could really interchange those. That's not a problem. Since it's addition, it works the same way. So really straightforward. And if I take the first problem, problem number 32, given x of t equal this, what is the x dt? Well, the x dt would be simply negative e to the negative t, the sine of 3t, plus 3e to the negative t cosine of 3t. Derivative of the first times the second, plus the first times derivative of the second. So same as product rule as we did back in the days. And there it is, done. That would be my answer, and that's the end of it. Basically the product rule. And if I had a 3 by 3, so what? If I take dx, dt, that would be, well, the derivative of each of those entries, that's twice the cosine of 2t, negative twice the sine of 2t, negative 2e to the negative 2t, negative twice the negative twice the cosine of 2t, negative 4 times the sine of 2t, and negative 6e to the negative 2t, and 6 the cosine of 2t, negative twice the sine of 2t, and negative 2e to the negative 2t. Again, that would be my answer, and that's pretty much it. Now, something that they're able to do in linear algebra, something impressive actually. They can take a derivative by multiplying matrices without using our traditional calculus. So they say, here's verify that the given vector functions satisfy the given system. Alright, here's the vector. What are you trying to satisfy? Take a derivative on one end. What's the derivative? Derivative of that will be 0, e to the t, negative 3e to the t. That should equal, what would multiplied by x? Isn't x 0, e to the t, negative 3e to the t? And if I really look at this, 3 by 3, 3 by 1, the outcome is 3 by 1. To generate the first entry, I use the first vector multiplied, bunch of zeros. To generate the second entry, I take the second multiplied. That will be 0 plus e to the t plus 0, which is e to the t. And to generate the last entry, I take the third multiplied. 1 times 0 is 0, plus 0 times e to the t is 0, minus 3 e to the t. And here they were able to do calculus by simply multiplying those two matrices. The question is, of course, how do you get this matrix? And that's to come. So instead of taking derivatives, I could simply find this matrix and multiply by it. And really quick, given matrices A and B, part A, integrate A of t. Well, how do you integrate a matrix? We just integrate each entry individually, and that would be t e to the negative 2t divided by negative 2, 3t, and e to the negative 2t divided by, you know what, I don't know why I'm writing this so small, and that doesn't look like a 2t. Okay, here we go. So that would be t e to the negative 2t divided by negative 2, 3t e to the negative 2t divided by negative 2, plus c sub 1, 1, c sub 1, 2, c sub 2, 1, and c sub 2, 2. If you would like to add those next to those, that's fine. It's the same thing. You could do that. That's pretty much it. And if I want to integrate in part B, the integral from 0 to 1 of e to the negative t, e to the negative t, negative e to the negative t, 3 e to the negative t, well, that would be negative e to the negative t, negative e to the negative t, e to the negative t, and negative 3 e to the negative t, evaluated from 0 to 1, identical to calculus. You throw the 1 in, and what we end up with, negative e to the negative 1, minus e to the negative 1, e to the negative 1, negative 3 e to the negative 1, minus, you throw the 0 in, that's a negative 1, negative 1, 1, and negative 3. So basically, the final answer is negative e to the negative 1 plus 1, negative e to the negative 1 plus 1, e to the negative 1 minus 1, and negative 3 e to the negative 1 plus 3. That would be my final result. Now, when they say find the derivative of AB, I could use the product rule, or if I really want, I could multiply those out first and take a derivative of that result, right? So when they say in part C, take a derivative of A of t, B of t. Again, I could use the property, or I could multiply first and do the results after. It's the same thing, it really doesn't matter. So if I really wanted to use, that will be derivative of the first, if I'm not mistaken, A times derivative of the second. So A is simply 1 e to the negative 2t, 3 e to the negative 2. What is wrong with the negative 2t? It's not coming out right. Multiplied by the derivative of b. Negative e to the negative t, negative e to the negative t, negative e to the negative t times negative, and negative 3 e to the negative t, plus, and if I look at this again, derivative of a times b. Derivative of a would be 0, negative 2 e to the negative 2t, 0, and negative 2 e to the negative 2t, times the derivative of b, which is negative e to the negative t, negative e to the negative t, e to the negative t, and 3 e to the negative t negative. Now I want to make sure I didn't make the same thing twice. I took a times derivative of b, a times derivative, oh, I did the same thing twice. Oh my god, what is wrong with me? a times derivative of b plus derivative of a times b. Derivative, okay, that one is right. Times b, just b, not a derivative. Yeah, I know. You know, I've never used that before anywhere. b is simply e to the negative t, e to the negative t, and if you multiply those out, that would be the final answer. Of course, it's a lot quicker, I think, if you multiply those out first, and then take a derivative. No biggie. That's same thing. So, in this section, we're just aiming to take some derivatives and untype because we need to do that in the next section, and that concludes this section.